what equation do I use to find time?
The first one.
So let's get rid of the ones that we don't want to use. All right. So I'm using this equation here. And so what's my displacement?
Negative 0.8
Equals
negative 2.25. 4.9 or negative 4.9.
and now solve for time. It's a math problem. It's a quadratic equation that probably is not going to factor nicely. It might, I don't know. How would you solve it?
Quadratic formula.
So what do you have to do to plug into the quadratic formula?
Just move everything over to one side.
All right. Now, this is my own personal eccentricity, one of many. I like the quadratic term to be positive, so I'm going to move everything over to the left. So 4.9t squared plus 2.25t minus 0.8 is equal to 0. So t equals negative 2.25 plus or minus the square root of 2.25 squared minus 4 times 4.9 times negative 0.8 divided by 2 times 4.9. If somebody would tell me the discriminant here, the part under the radical first. This whole thing comes out to 9.8? Or you're just doing that part?
Yeah, I was doing
The part under the radical.
20.7.
Within the radical.
I got
Pardon?
19.45.
20.45?
No, 20.74 is what I had.
You got 20.74?
I got that as well.
Is that right?
Okay. It's positive, so I'm feeling encouraged that we've done something right. And now the square, so this becomes negative 2.25 plus or minus the square root of that over 9.8. Square root is going to be 4 point something. 4.57. What is it?
4.55.
5.5. Now I am going to get two answers here, one of which will make sense physically to this problem and one of them won't, but it does have a meaning to it. So I got time is equal to, what are my two answers? And
Negative 0.7.
negative 0.47,
0.7.
negative 0.7. Is that what you said? Okay. Which is the correct answer?
Positive.
Yeah. What does the negative 1 mean?
Nothing?
There's a mathematical meaning to it.
Well, it's one of the x-intercepts.
Yeah. Physics got us to, and definitions got us to here, it becomes a math problem. What the math problem is trying to figure out is, I've got some coordinate system. And I have a parabola. We are starting out with it's going in that direction, so I probably should draw that a little bit differently. The time is 0. So when time is 0 here, we're trying to figure out what time it hits that. But mathematically, it's also calculating this spot right here. Now, based on the fact that it started out going down in that direction, I got a parabola here, I would expect this to have a larger magnitude than this. And indeed it does. That distance there is 0.7, and that distance there is 0.235. So I'm feeling good that something was done right, at least. If it had been shot upwards, I would expect the positive answer to be greater in magnitude than the negative answer. But we now have the time, it's in the air. 0.235 seconds, if I remember correctly. 235, yeah. 0.235 seconds. Again, that's the only thing that's going to be the same for both of them. And so now, ultimately, I think part D was to find this value right here. I'm using R for range, but it's going to hit the ground, and it's going to be whatever that is. Which formula do I use now?
It's the same formula, right?
Yeah, I mean, we have options, but yeah, that works. Probably should not use the marker on it. So now, what I'm trying to find in my mixed colors, it's 3.89 times 0.235 lost 1/2 0 0.235 squared. In essence, 3.89 times 0.235, whatever that is.
Which part are we trying to find the R for?
I thought part D was how far from the bottom of the table does it land?
This one, oh, that's part E. So that's,
That would be part C, if I'm recalling correctly, part C is what's the time, and part D is how far from the bottom does it land.
Part D is how fast it'll be before it hits the ground.
Oh, I apologize.
so the final velocity,
Yeah.
vertical.
So part D was finding this. Well, horizontally, what's going to be my final what's the horizontal component of my final velocity?
Like 3.89.
Yeah, there's no change. Acceleration is 0, so there's no change in velocity, 3.89 meters per second. And so this, what formula do you want to use for that? In other words, what equation has VF in it?
Final velocity equals initial velocity equals acceleration times time.
That's probably the simplest one. So if I plug into VI is equal to VF plus AT. Try that one again. VF equals VI plus AT. That's going to be negative 2.25 plus negative 9.8 times 0.235. And they get you something. Now, I think it was in 251 class, I went through an example where I changed the numbers, and lo and behold, when somebody handed in the master set, they had the numbers that matched exactly what I had written on the board. Please recognize, 4.5 is not the correct starting point for this. judging from your expressions, I think I can safely say that all of us feel like this was a fun little problem. Questions? And on the first test, there will be a projectile motion problem. You can pretty much be guaranteed of that. Just be aware. The critical thing to recognize is that when you start plugging into the equations, it's strongly recommended. It's possible to do it different ways. It depends on how sophisticated your trig is, but when you're plugging into the equations, plug in the vertical numbers or plug in the horizontal numbers. Don't mix and match. Acceleration horizontally is 0. Thus the 0 right there. Vertically, it was negative 9.8. This comes from 1/2 negative 9.8. That's where negative 4.9 comes from. Questions? Other questions?
Could you go over what percent error is?
All right, so whenever you're trying to figure out how accurate your answer is, you need to compare it to something. Our two choices are percent error or percent difference. Percent error says, I know what the correct answer is supposed to be, I'm going to compare it to that. Percent difference is, I don't know what the right answer is supposed to be, so I have to come up with a guess at what the correct answer is. So if the correct answer is 55, so this is I'm going to put correct in quotation marks. Correct could be, it is the predicted one, it's the expected one, it is the theoretical answer, whatever it happens to be. So if my correct answer is 55 and I get 47, so this is my experimental. Unfortunately, expected and experimental start with the same 3 letters, and so sometimes EXP means expected and sometimes it means experimental, so hopefully I will come up with a different way of doing that in some places. But this is what I got, and I'm comparing it to this. So first thing, what's the difference between the two? If you do 47 minus 55, I recommend taking the absolute value, but if you leave the negative in there, I don't take off of that. Some instructors will care. That's one of the places I don't. Now we end up with 8 here. Is 8 a big number or not? Well, we have to compare it to the correct answer, so we divide by 55. So it's 8 over 55. It'd have been nice if I picked numbers that worked out nicely, and then times 100%. Put in percent form. Get
14.54.
percent. So that would be the percent error. The other one is percent difference, where I have a difference between 2 values. I calculated the same thing twice. I got 2 different values here. I don't know which one's correct. So for percent difference, this is percent error. And again, error implies that there's a mistake somewhere, that we're trying to figure out how far off we are of something correct. Percent difference, I have 2 values, but I don't know what the correct answer is. So if I got 37 and 25, that's a huge spread there. But if I got those 2 as my 2 values that I calculated independently, first thing I do is I get the difference between them. Now I have to compare it to something, and since I don't know what the correct answer is, I'm assuming that they are equally correct or equally incorrect. In other words, I'm going to divide by the average of the two. So that becomes 12 over 31. And then to put it in percent form. It's about 40%, 39.2.
38.7.
Now, at some point in a lab, you might be faced with, should you use percent error or percent difference? And that comes down to, if you do it two different ways, but you have a lot more confidence in one method than the other, you might want to go with a percent error, assuming that the one that you have much more confidence in is far more correct. Or they're both found experimentally, we'll do a percent difference. Other questions? Okay. Oh, it's not that one. That's the one. All right, let's go through a standard projectile motion problem. And I know there's videos on this also, but repeat some stuff. Let's make this 100 meters per second, which is about 210 miles an hour or so. An angle of 37 degrees, a height of 50 meters. And what I want to know, just basically, how far from the base of the cliff will this object land? Oh, one comment on the last one. The question was, what is the velocity, the final velocity? I don't know if I worded it as just before it touches the ground or what's the final velocity. In a projectile motion problem, if I ask what's the final velocity, I'm asking for the velocity just before it touches the ground. Because once it touches the ground, we now have an additional force involved, and so therefore acceleration is not constant anymore. So it's just the language in physics classes that if I ask what's the final velocity, when it hits the ground, what's the final velocity? The final velocity is not zero. It's supposed to be understood, it's the velocity just before touching the ground. Make sure that's still going. Okay. All right, so with any problem like this, actually, what do we do?
Make I jet.
Okay, how do you want to define it?
It's normally J and then I.
You want to stick with that?
Yeah.
Okay. All right. If you don't like that, blame Ethan. or the math people. If you have it being projected in the other direction, then you can still stick with this or flip it around. Yes, Jakai?
Underneath the, arrow?
What's this?
Yes.
37 degrees. It's being projected 37 degrees above the horizontal. Now, let's say that we get into, there's a problem and I start using horizontal, vertical. Again, wide variety of students over the years. Some people get horizontal and vertical mixed up. If you can think of the horizon, it's horizontal. Or just ask. Don't lose out on the problem because of the vocabulary of horizontal versus vertical. Now, most people are fine, but not, I've had enough. I've had students in the past who got that backwards. All right. Now what? We've defined our coordinate system.
Make the chart, the horizontal vertical chart.
All right, so I got my horizontal, I hat, and my vertical, J hat. And I have my displacement, initial velocity, final velocity, acceleration, and time. All right, before we do anything else, what do we know?
Vertical displacement. Wait, yes, vertical displacement.
What's the vertical displacement?
Negative 50.
Give me the whole thing.
Negative 50 J.
Units.
Meters, sorry.
Meters. All right, so, and just to make it pop, we'll use a different color here. Ooh. All right. We can fill in, of the 10 spaces there, we can fill in 2 more spaces before we have to do any math.
Is the initial velocity 100 meters per second? In the I direction?
Oh, no.